Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question, binary tree cameras. You are given the root of a binary tree. We install cameras on the tree nodes where each camera at a node can monitor its parent, itself, and its immediate children. Return the minimum number of cameras needed to monitor all nodes of the tree. For the example 1, the minimum number of camera is just 1. We just place a camera at the second level, so it can monitor itself, the immediate children, left child, right child, and then its parent. In example 2, for this tree structure, we need to place 2 cameras. One camera is here, so it monitors itself, the parents, immediate children. This camera is placed here, monitor itself, and then the immediate children. So at least 2 cameras are needed to monitor all nodes of the tree. So how to solve it? So let's take a look at the tree. So the optimal strategy is, let's say, starting from the lowest level, from the leaf node. And then a better strategy is not to place the camera on the leaf node if it has a parent. I mean, let's say if you place a camera here in the leaf node, then this camera can only monitor itself and then its parent, because this leaf node does not have any child. So in that case, if we place the first camera here instead of the parents of the leaf node, then we need at least 1 more cameras. So the minimum number of cameras will be 3. So the optimal or the better strategy is always to place the camera on the parents of the leaf node instead of the leaf node. So that's kind of the strategy to place the camera. So in this case, so then how should we write a code to solve this problem? So we are keep tracking of the state of each node to indicate if this node needs to be covered by the camera, or do we need to place a camera at this node, or this node has already been covered because its child has a camera already placed. So the strategy to place the camera is we start from the bottommost level, so start from the leaf node, and then we traverse the tree from the bottom up, from the leaf to the root, and then we place the camera. So in that case, let's keep track of the function, a helper function. So what this helper function return is the state of the node. 0 means, okay, needs not covered yet, needs to be covered. 1 means, okay, place the camera here. 2 means, okay, covered that camera placed. So that's what this helper function does. So if not node, this node is none, we just return 2. So we assume it's already been covered because it basically is empty. So in that case, we just assume it has already been covered because we do not need to place the camera for the empty node. Else, let's try to get the left, right equals helper, left, helper, right. let's say in this case, if left equals 0 or right equals 0. So in this case, it means, okay, one of the child is not covered and it needs to be covered. So in that case, we need to place a camera at this node in order to cover its child. So in that case, we need to keep track of a result variable. So similar as before. So set this result to not local to keep track of the number of cameras. And then here we need to place a camera at this node. So in that case, we increase the result by 1. We increase the number of camera by 1. And then we also need to return. So since we already placed a camera here, we just return 1. Else, if left equals 1 or right equals 1, which means, okay, there's a camera on one of its child. So in that case, this node is already covered. It's covered by its immediate child. We just return 2 to indicate that this node has already been covered by the camera. So let's say else. So in that case, we just return 0, which means we need to place a camera here. Sorry, my bad. So we return 0, which means this is not covered yet, and it needs to be covered. And then we just call helper function for the root. And then after that, we just return result. Oh, I forgot. Okay. So this should be node dot left, node dot right. Okay, I got the wrong answer. Oh, I see. Now I see the reason why I got the wrong answer. So I need to return. Okay, so the mistake I made was previously I only return results, and then I forgot that for this root, let's say if this root is not covered and it needs to be covered, we need to place a camera at this root. So that's why I add this one to the results. Let's say if the helper root equals 0, which means this root is not covered and it needs to be covered. And in this case, since it's already the root node, so it does not have any parent to place the camera in its parent. So in this case, we place a camera at the root. So that's why we add this one. So basically the idea for solving this problem is relatively simple. We just so by walking through the example, we know the best strategy is from the bottom and from the leaf node to the root node. And then to be able to actually minimize the number of cameras needed, we do not place the cameras at the leaf node if it has a parent. So it's a better strategy to place the cameras at the parents of the leaf node. So we just return the state of each node. That's kind of what this helper function does. If the state value is 0, it indicates it's not covered and it needs to be covered. So if it's 1, which means, okay, we place a camera here. If it's 2, it means it's covered by a camera placed. And then we use the result to keep track of the number of cameras. And then we declare this as non-local. So if this node is none, so this node does not exist, we just return 2. So basically, we do not need to cover this empty node. So we just return 2. And then after covering the edge cases, we just check the left child and the right child of this node. If the left child or right child, if one of the child is not covered and it needs to be covered, then we need to place a camera here at this node in order to cover this node's children. So that's why we increase the result by 1. And then we return the value 1. This indicates, okay, we have already placed a camera at their node. If the left equals 1 or right equals 1, which means, okay, there's a camera placed in at least one of the one of the node's child. So in that case, this node should already been covered. So in that case, we return value 2 to indicate that this node has already been covered by the camera placed. Else, so this node is now covered and we just return 0. And then in the end, we return the result plus the helper root equals 0. So this is to cover some edge cases. Let's say if you only have a one root node. So if you indicate that there is this root node is not covered and it needs to be covered, in this case, we need to place a camera at this root node because we do not have a parent. So this root is already become the root of this tree. So it does not have any parent to place the cameras. So in this case, we just place one camera here. So that's why we add this one to the result. So that's kind of our solution.